Consider the function L of x is mx plus c. Let R be the root of L of x is equal to 0. If m, r, and c in that order are in arithmetic sequence, then L of x is said to be an AS linear function. A shows that L of x, which is equal to 2x minus 1, is an AS linear function, 2 marks. So we need to show that gradient, root, and y-intercept form an arithmetic sequence. What is gradient? It's just a value in front of x, it's 2. Y-intercept, it's negative 1. Let's find the root, so y is 0, x is r, minus 1, so r is a half. And let's consider 2, half, and negative 1, and how to show that these three values form an arithmetic sequence. The first way is to show that there is the same common difference. So let's consider the second one is the first. Half minus 2 is negative 3 over 2, and negative 1 minus a half, it's also negative 3 over 2, and we write a conclusion since there is the same common difference. So 2, half, and negative 1, which are m, r, and c, form an arithmetic sequence. So L of x is an AS linear function as required. Or another way is to use the next property for an arithmetic sequence. For example, 5, 10, 15, 20, you can see that any value, it's average or mean of two adjacent values. For example, 10, it's 5 plus 15 over 2, 15, it's 10 plus 20 over 2, and you may use this property here. The next. Consider L of x to be equal to mx plus c. Show that r is minus c over m, 1 mark. R it's a root, so it's just 0 is m r plus c, so r is m minus c over m as required. Next, given that L of x is an AS linear function, it means M, R, C form an arithmetic sequence. Show that L of x is mx minus m squared over m plus 2 for max. So we need to show that this statement is true. So we should get this expression for L of x. And we can see that m remains the same, but we need to get c in terms of m only. And here we can see that c can be represented in terms of m and r. So we need some additional equation to get rid of r here. For example, we can use that m, r, and c form an arithmetic sequence, and let's write, for example, the same common difference. So r minus m is c minus r. 2r is m plus c. So r is, or actually we can get r here, and 2r is negative 2c over m. So m plus c is negative 2c over m. Let's multiply each term by m. So m squared plus mc is negative 2c. Let's move it negative 2c to the left, so it becomes, and factor out c, so it becomes m plus 2c is negative m squared, so c is negative m squared over m plus 2, and substitute into this, and we get as required L of x is mx minus m squared over m plus 2. Next, state any further restrictions on the value of m. 1 mark. We can see that m plus 2 can be equal to 0, so that when m is negative 2, division by 0 arises here, which is impossible, so we should say that m cannot be equal to negative 2, so negative 2 should be excluded. Also, we can see that m cannot be 0, but m is not 0, it's already given. Next, there are only 3 integer sets of values of m, r, and c that form an AS linear function. One of these is L of x is negative x minus 1, and m, r, c are integers. C. Use part B to determine the other two AS linear functions with integer values of m, r, and c, 3 marks. Let's consider given example. We can see that m is negative 1, and we can see that our set becomes m, and let's consider everything in terms of m. R is minus c over minus 2c over m, and what is c? C is this, so it's just m plus 2, m over m plus 2, and y-intercept is negative m squared over m plus 2, and we need integer values, and when m is negative 1, we get negative 1, negative 1, negative 1. And you may notice that if m is negative 1 plus 2, it's 1 in the denominator, so actual denominator disappears and fraction disappears, and so that it becomes integer. But for what other value of m, we can get denominator to be not 1 because it's already used, but negative 1, because if it would be negative 1, it will be some integer or negative over negative 1, and it also will be integer. Definitely it's negative 3. Let's check m to be negative 3, and we get negative 3. Just substitute into these expressions, negative 3, 3, and 9. Let's check plus 6 plus 6, so it's an arithmetic sequence, and it's the second sequence, and so we need one more. How to find it? If you consider the same common difference and consider this minus this is this minus this, you get just 0 is 0, so it's not useful, it gets nothing. Definitely, since they are integers, these must be integer, and it's a fraction. So what does it mean? It means that m over m plus 2 must be some k, where k is some integer, and m is integer times m plus 2, m is km plus 2k, and let's solve for m. So 1 minus k over m is 2k, so that m is 2k 1 minus k, and k is integer and m also must be integer, and by trials and errors we can see that again here when k is 2, we can see m becomes -4. And hence our set becomes -4, -4, 2, and 8. It's actually the easiest way. There is another way. We know that the second term it's also what? Minus 2c over m, minus 2c over m, and we need another parameter, so that if we consider, and now we can consider we can equate just this. In general, we can try, if there is some another parameter, try to consider common difference, but it may be more complicated, but actually the general idea is the same. Let's just equate this, and it's very important that we should get integer values, so it's -2c over m, and if you solve this quadratic, and if you rearrange and get quadratic in terms of m, so you get the same. I just write an example: cm plus 2c is equal to 0, and discriminant becomes c squared minus 4 times 2c, and if you try to find roots becomes m is -c plus minus root c squared minus 8c, or c minus 8 over 2. And again, since m must be integer, definitely this must be such a value so that square root can be taken. And here here definitely c cannot be 0, but when c is clear, then when c is 8, you can see this is 0 and m becomes -4. It is the result again. And you find this and this, because m is -4, and check. Yes, it's an arithmetic, so it's the required answer. But if we try other possibilities, possible values may be also c may be 9, so m can be -9 plus minus 3 over 2, and it may be -6 or -3, and r is or you may check these values for m, and it doesn't form an arithmetic, and this forms an arithmetic, and you get -3, 3, 9. So two required answers, or two required sets, are this. So it was C. Next, consider the function q of x is ax squared plus bx plus c for x is real, where a is real, a is not 0, and b, c are real. Let r1, r2 be the roots of q of x is 0, d. Write down an expression for the sum in terms of a and b, 1 mark, and the product of roots. So just use sum and product rule. Sum it's minus b over a, product it's c over a, and that's all. If a, r1, b, r2, and c in that order are in arithmetic sequence, then q of x is said to be an AS quadratic function. Given that Q of x is an AS quadratic function, write down an expression for R2 minus R1 in terms of A and B, 1 mark. And since there is only 1 mark, it must be easy. So since these 5 values are in arithmetic sequence, what we can use the same common difference, so we can say that B minus R1 is R2 minus B. Oh no, R1. Oh, actually it's correct, but it gets nothing, and we can write what R1 minus A is the same as R2 minus B. Yes, it's suitable. Yes, and hence R2 minus R1 is B minus A. R2 minus R1 is B over A. Next, use your answers to parts DI and EI. What is DI? DI, it's sum and product rule. EI, it's this expression to show that R1 is A squared minus AB minus B over 2A, 2 marks. So we can see there are R2 and R1, but we need R1 only. R1 only, and we can do it is given that we should use this result, so it will be more easier to use this one. So we need R2, so R2 is minus B over A minus R1, and hence we get the minus B over A minus R1 is B minus A. So negative 2 R1 is B minus A plus B over A. Let's do common denominator A, so AB minus A squared plus B, and hence R1 is 2A, and divide by negative 1 every term, so it becomes A squared minus AB minus B as required. Next, use the results from part E from this result to show that B is equal to 0 or A is negative a half, 3 marks. And we consider that Q of x is AS quadratic function. It means that these values form an arithmetic sequence. So what can be used? So R1 is this, and we need some another equation so that we can solve it. Let's consider this one. Yes, and we can consider these three terms, and R1 it is average of A and B. So let's try use that R1 is A plus B over 2, and let equate. So it becomes A squared minus AB minus B over 2A is A plus B over 2. 2 cancels, and let's multiply both sides by A, so it becomes A squared minus AB minus B is A squared plus AB. A squared cancels, so let's move everything to the right, and it becomes 2AB plus B is B, 2A plus 1 is 0, so B is 0, or A is negative a half as required. Q of x to be an AS linear function. Consider the case where B is 0. F. Determine the two AS quadratic functions that satisfy this condition. So again, A R1, B R2, and C form an arithmetic sequence, and since B is 0, so it's directly 0, and let A be A. What is R1? R1 is this one, but when B is 0, we can see that it becomes just A over 2, 0. And what is R2? Where is it? Yes, R2 is this one, so it's minus B over A minus R1 minus B over A minus R1. So R1 is A. Let's check. So R1 is A over 2. Oh, but B is 0, so it's just a negative A over 2. Yes, so just negative A over 2 because B is 0. And C, what is C? Where is C? How to find C? And C, and here we can see that common difference in terms of A, it's just what, negative A over 2 or minus A over 2. And it seems to be minus A. A over 2, 0. and we need some equation and what equation can be used to find C. We can see this one, and R1 R2 is C over A. Let's consider this one. So R1 times R2 is minus C over A. So what is R1 is A over 2 times negative A over 2. So it's minus A squared over 4 is minus C over A. So C is A cubed over 4. And also it must be negative A. It's from common difference. So A cubed over 4 should be negative A. Definitely A cannot be y minus C over A. Product is C over A minus plus here, so it's minus plus. Yes, A cannot be 0, so we can simplify. So A squared is 2, so A is plus minus A squared is 4 and A is plus minus 2. And if we know A, we know everything. And what do we need here? Actually, we need this function q of x, which is an AS quadratic function, and it's of the form ax squared plus bx plus c. So b is 0 and a, if a is 2, we get 2x squared, and c is negative a, so 2x squared minus 2, and another variant, it's when a is negative 2x squared plus 2. Okay. Now consider the case where a is negative a half. I find an expression for R1 in terms of B. So what is R1? R1 is this, and we need just substitute negative a half for A and get expression in terms of B. So R1 becomes, or it is equal to a squared minus ab minus b over 2a, and it becomes 1 over 4 plus half b minus b over negative 1, and it is equal to a half b minus 1 over 4. Next, hence or otherwise determine the exact values of b and c such that as quadratic functions are formed. Give your answers in the form negative p plus minus q root s over 2, where p and q and s are positive integers 5 marks. So we need b and c B and C. Okay, and again R, R1, B, R2 and C form an arithmetic, and A is negative half here, R1 is half B minus 1 over 4, and it seems that everything will be in terms of B. R2, what is R2? We can use actually previous formula, or from here we can find common difference. It's just a half B minus 1 over 4 minus negative a half, so plus a half, it becomes 1 over 2b plus plus 1 over 4, and hence R2 becomes B plus common difference, so it becomes 3 over 2b plus 1 over 4, and again 3 over 2b plus 1 over 4 plus 1 over 2b plus 1 over 4, so it becomes what? 4 over 2b, it's 2b plus a half. And definitely we need value of b, and here we can try to use just subtract 2 is equal difference, so 2 adjacent is equal to difference of 2 adjacent, but if we do that, we get again 0 is equal to 0. We need another information, and what information can be used from the previous, or actually in general we can use, for example, that product is C over A. Why not the sum? Because I think that if we use the sum, we get again 0 is equal to 0. So C is equal to R1, R2, A. It's just from sum and product rule. And we can get equation in terms of B. And so 2b plus a half is equal to R1, so it's a half b minus 1 over 4 multiplied by 3 over 2b plus 1 over 4, and multiplied by negative a half. Okay. So common denominator 4, so it becomes 2b minus 1 with this minus, 2b minus 1, so it will be 1 minus 2b. Common denominator for here 4, so it's 6b plus 1, and this 2, and 2b plus a half, and Let's multiply both sides by this 32, so it becomes 64 plus 16 is, and expand, so it's 6b minus 12b squared minus 2b or 6b and plus 1, 64b, and let's move to the left, so it becomes 12b squared plus 64b minus 6b plus 2b plus 15 is 0, 12b squared plus 60b plus 15 is 0. We can divide by 3, 4b squared plus divide by 20b plus 5 is equal to 0. Discriminant becomes 400 minus 4 times 4 times 5 is 4 times 80, and it's 4 times 16 times 5, so root of discriminant is 8 root 5, so roots are minus b plus minus 8 root 5 over 8, we need over 2, so it becomes negative 5 plus minus 2 root 5 over 2. And actually, what do we need? Now consider the case where a is negative a half. Find an expression for r1 in terms of b. Hence, otherwise determine the exact values b and c such that as quadratic functions are formed. We need just b and c. We don't need an expression for quadratic function. Yes, so b values are found. And what is c? It's just here. C is to b plus a half. C is to b plus a half, so it becomes negative 5 plus minus 2 root 5 over 1 plus a half, a common denominator, so it becomes negative 10 plus minus 4 root 5 plus 1, so it becomes negative 9 plus minus 4 root 5 over 2. So the required b values and the required c values. And that's all for this question.